Okay. So already touched on intersection. Okay, in briefly touch on intersection yesterday, right? So today we're going to look at examples, okay, on intersection. So you look at example 4, right? Based on your okay, based on your notes. All right. So example 14 is given that the universal set is as integer from 1 until 10. So P is an odd number, X is an odd number, Q is a prime number, and R is a multiple of 3. So list all the elements of the following set. Okay. So what are the elements? Okay, for odd number, so it's 1, 3, 5, 7, and 9. Okay, so for set Q is a prime number, so it's 2, 3, 5, 7. Right? So, and then our set R is a multiple of 3. So multiple of 3, start with 3, 6, and 9. Okay, so list all the elements of following intersection of P intersect Q. So P intersect Q, okay, so we find the common elements between P and Q. So you can see here, set P and Q both has 3, 5, right? 3, 5, 7. All right. So therefore, our P intersect Q, we have the elements 3, 5, and 7. Right. So meaning that P intersect Q is another new set. Right. So new set form. Right. So if about P intersect R, so P intersect R, you look at P and R. What are the common? So the common elements between P and R. So you can see here 3 and 9. Okay, 3 and 9. Right. So therefore, P intersect R, we have element 3 and 9. Okay. So now we go to Q intersect R. Q and R. So I'm going to use a blue color. So Q and R, what are the element, the same element, common element? So you can see here also 3. Okay, and then 2, 3, no more. Right? So it's only one element. So therefore is set with element of 3, one element only 3. So the next one will be P intersect Q intersect R. So on P intersect Q, okay, P intersect Q, we have 3, 5, 7. So R, okay, you look at R, okay, 3, 5, 7, and set R here. So it's 3 only, right? Or you can see from this P intersect Q, P intersect R, and Q intersect R to find the common elements, right? So there is only one, that is 3 lah. So this is the element for P intersect Q intersect R set. Okay, now this is list down, right? So hence, okay, we go to D first. So what are how many elements, number of elements in P intersect Q? So you can see N. The small n in front means the number, right? The number. Okay, so the number of P intersect Q is 3. So the number of P intersect R is 2. The number of P R intersect Q is, or Q intersect R is 1. And the number of P intersect Q intersect R is also 1. Okay, so now we need to draw a Venn diagram of represent set P, sorry, not Q, not ABC. So P, Q, and R. And then we're going to shed the region, right? So P intersect Q. So there are 3 sets inside here in the universal set. So, okay, so we start off the universal set. Okay, so this is universal set. So P we have 1, 3, 5, 7, 9. So 1, 3, 5, 7, 9. So the common common elements between P and Q is 3, 5, 7, right? So we draw. Right, so I make it big so that I can right. So 3, 5, 7. So 1, 3, 5, 7, 9. Right? So 3, 5, and okay, I think to erase this. It's too small. P so here will be 3, 5, and 7, right? And then there are 9 here. Okay. Is set P, set Q. So odd numbers. Okay. So you can see here odd number. P is 1, 3, 5, 7, 9. Then Q is prime number. So it's 2, 3, 5, 7. So 3, 5, 7 is here. So 2 will be outside the intersection point. Okay. And then one more is R is 3, 6, 9. So 3, 6, 9. Okay, so this is 6 here. So this is set R. So meaning that from here, you can see that Q intersect R on only 3. So here is empty. Empty means nothing inside, right? So how to shed P intersect Q? So I use a highlighter. So P intersect Q is this yellow region, right? Okay, and then P intersect R, so we need to draw another one. So it's quite tedious. Okay, so just draw like this. This is P, this is Q, and this is R. Okay, so P intersect R, it will be 9 and 3 inside. Okay, so I highlight with green color. So this is the area, right? And for Q intersect R, I should this. So in Q intersect R, so we need to draw another one. Okay, that is set E, so I need to use smaller one. Okay, this is R, Q, and P. So okay, so this one you can fill in yourself. So this one, this is 6. Sorry, this is 9. This is 6. And then this one is 5 and 7. All right. So apart from that is 1, 2, 3, 5, and then 4 outside, right? And then also 8 and 10. So you can fill in here later on. 8 and 10, right? So Q intersect R will be this area only. So if you shed like this also can, but here is no value, no elements, right? So it's okay. So this is how you draw a Venn diagram to represent the area, right? The area of P intersect Q, P intersect R, and Q intersect R, right? So now we go to state the number of elements or list all the elements of the following intersection of set. So it should be complement, complement of set. should be complement, huh? So never mind. So what is P intersect Q again? Huh? P intersect Q, we have P intersect Q. Okay, still remember it's 3, 5, 7. So P intersect Q prime will be other than listed here is 1, 2, 3, then 4, 5, 6, 7, 8, 9, and 10. So this is P intersect Q prime. So P intersect R prime will be apart from P intersect R. So P intersect R, we have 3 and 9, if not mistaken. So P intersect R prime will be 1, 2, 3, 4, 5, 6, 7, 8, and 10. All right, this is P intersect R. Then this P intersect R prime. So you add these two together, these two set together, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is the universal set. So 3 and 4, we are going to find the number of elements in Q intersect R prime. So the number of Q intersect R, okay, we go back to this question, is Q intersect R, is R intersect Q is 1, okay? So 1 here. So therefore, the number of element of Q intersect R prime will be the number of universal set minus U intersect R, that is 10, right? Correct or not? 10 minus 1, you get 9. So you double check. So there are elements 1 until 10. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 elements in universal set. You minus 1, you get 9. And then the number of P intersect Q intersect R prime is also 9, because the number of P intersect Q intersect R is 1. Okay, so therefore you get the same value. So how to sketch it? Okay, so sketch. All right, so sketch. So P intersect Q prime. So okay, this is P intersect Q prime. So this is P, this is Q, this is R. Okay, so where is the area? P intersect Q is here. So the area of P intersect Q R prime will be everything. Okay. This is the area. Okay. So this is the area of P intersect Q prime, the yellow area. Huh? Then we go to P intersect R prime, intersect prime. Okay, the same thing. This is R. So the area of P intersect R prime. So will be everything here. Okay, outside P intersect R. Okay, so except this part. This part is P intersect. Okay, so here, whole thing. This white area will be P intersect R. Okay, so we go to Q intersect R prime. So Q intersect R prime. So P, okay. So this is Q and R. So if you want to make it more beautiful, I think more relevant, you can do like this. This is R. Okay, so this is Q. So we don't touch on that side. So it's P Q intersect R prime. So it will be the green area, whole thing. Okay, the whole thing, excluding the area that Q and R intersect. Intersect means the common area between Q and R. Okay, so this is the answer. Okay, so this white area will be Q intersect R. Okay, so maybe some of you will ask teacher, can I draw like this? So it's okay, right? If this is empty. So actually you need to label it. So here is 3, 7 and 5. This is 3. This is 9. This is 1. Right? And then this one nothing here inside. Okay. So this one is 2. And then this one is 6. And this one is 4, 8, 10. Okay. So this is how you shape the area, draw a Venn diagram, and shape the area that represent intersection of two sets or the complement of intersection of two sets. Okay. Okay. So I think it's quite clear. So we go to example 15. Okay. Example 15 is almost the same as example 14. Okay. So you need already listed out the elements for universal set G, set H, set K. So now we just need to find out what is G intersect H. So G intersect H will be the common element between G and H. So I use highlighter. So G and H, you see here, these two. G, so Q and Q, they are Q. P, no. R, so they are R. U, V, W, here, no. Right? So the answer is very straightforward. So it's Q, R, and U. Okay. So how about G intersect K? G intersect K. So G intersect K. So we use green. G and K. So you see here Q, still Q got. T, U got. And V. Okay, Q, U, V. So here is Q, U, and V. Then we go to the next one, H intersect K. So H intersect K. So now I use blue color to represent the common element between H and K. So again, we have Q. Sorry, blue. Red. I think red better. Q. And then UV. So U also got. And T. No V. Right? So the answer will be Q, T, and U. So the last one, G intersect H intersect K. So we'll find the common elements in between these three sets. Okay, so I use blue, this one. So you can see here all got Q, Q, all got U. Okay, then there are different elements R, V, T in the respective set. Therefore, our answer will be Q and U only. So this is how you solve the problem. Right, so this is example 15. So we go to example 16. Okay, 16. The universal set is 1 to 8. Okay, 1 to 8. So we have set A 2, 4, 6, set B 2, 6, 7, and set C is prime number. So prime number is not given, so we list out first. Okay, so it's prime. Prime number is 2, 3, 5, and 7. Okay. So between 1 and 8, prime numbers are 2, 3, 5, 7. And what is a intersect B? Draw a Venn diagram to represent each of the following. So before that, okay, so we need to know what is A intersect B. Right? So A intersect B. So you have A intersect B, you can see here, highlighter. Yeah, 2, 6. Okay. So here is 2, 6. So B and C, so prime number. Okay, so again, B and and C, before you can draw, we need to know the intersection between A and B, A and C, B and C. So B and C will be 2, okay, 2 here, and 6 no, and then but you got 7, 2 and 7, right? Then we have A and C. So A intersects C, so you have 2 also. Okay, 2, right? 4 no, 6 no. So we have only 2, right? So A intersects C. So we have A intersect B intersect C. We have one element that is 2. So now we can sketch. So draw the graph. Wow. So A will be the C will be the largest, right? 3, 2, 3, 5, 7, right? 2, 3, 5, 7. So maybe we can draw C first. I use to this 3, 5, 7. So 2, this one, sorry. Oops. Okay, better off. This one is again C is square C, and B 2 and 7, 2 and 7. B is 2 and 7, and B is 2 and 6. Okay, 2 and 7. Okay, and then A and C is only 1, right? So, sorry, 6. Okay, so this is B. So here in the middle is 2. Okay, something's wrong. Now, okay. Sorry. I think I better just draw this normal one. This is B, this is 7, and this is 6 here. Okay. So 4. The A will be here. So here is 2, and then this is set A. So nothing inside here. Okay, so 2, sorry, this one is 4. 2, 4, 6. Okay, and then 2, 6, 7, B, and then prime number 2, 3, 5. So 2, 3, and 5. The rest will be outside here. So it's 1, 2, 3, and then 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so where is A intersect B? So A intersect B. So A intersect B will be the area between A and B. So it's this area. Okay, so this is A intersect B. So after you have the first experience here, then we can draw a better one. All right. So actually, we need to plan our our Venn diagram actually. Okay. So I think I better now. I have a rough idea what to do. So this is B, C, B A is A. Okay, so this one is ABC. So, okay, never mind. Change it. So this is 3, this is 5, this is 7, this is 2, this is 6, this is 4. Right? So here is 1, 2, 3, 4, 5, 6, 7, and 8. So here is, I think, the first one is not correct, right? So here no 6 and no 4. Okay, only 1, 8. Okay, so it's quite blur. All right, so what is the area between A intersect B intersect C prime? So it's outside this common area. So this is this is blue. Blue is A intersect B intersect C prime. This is the area. Okay, so the area here will be yellowish. So everything exclude the blue color. Okay, so this is the area. Yellowish color will be the A intersect B intersect C. All right, so you can improve this Venn diagram, right? So maybe you can do a triangle shape here. Okay, so I improve this Venn diagram. So okay, start to have this idea. So still using C, using this, and you have triangle. Let's have a triangle. Okay, triangle. Okay. And I also have a triangle here for A. This one is B. So I have 2 here. This one is 6. This one is 7. This one is 3. This one is 5. And then this one is 4. Here outside 1. And this one is 8. All right. So okay, then it will be more nicer. Okay, you can rearrange it. Okay, so you arrange later on. Okay, I think I arrange it. So here I redo. Sorry. Okay. So this one just now. So we have triangle. Then we have bigger triangle. Right? So we can start to 3, 5, 7. This is B, set B. This is set A. And outside 1 and 8. This one universal set. This one inside is common element 2. And this one is 6. This one is 4, right? 2, 4, 6. Okay, for set A, 2, 6, 7 for set B, and then set C is 2, 3, 5, 7, and then outside C, B, and A is 1 and 8. So this one is much okay lah, huh? This one much okay. Okay. So sorry for the sketching of Venn diagram. So sometimes you need exercise for it, huh? Right, so we go to example 17. Exercise for how to draw a Venn diagram. Okay, so now example 17. So is between, the x is between 1 and 15, including 1 and 15, but it's an odd number. So be careful. Huh? So therefore, our universal set is 1, 3, 5, 7, 9, 11, 13, and 15. So altogether 1, 2, 3, 4, 5, 6, 7, 8. So there are how many elements? So there are 8 elements for universal set. Okay. Then m intersect n. So what is m? M is the number from here. Universal set is divisible by 5. That means 5 and 15. Right? Then n is a multiple of 3. From here, multiple of 3 is 3, 9, and 15. 3, 9, and 15. So what is m intersect n? So m intersect n. So if I use highlighter, so it will be 15. Right? So and how many elements of m intersect n prime? So is the number of universal set minus the number of m intersect n. Therefore, it's 8 minus 1, you get 7. Okay? Or you can list it out, m intersect n prime, right? So you list out m intersect n prime. Apart from 15 is 1, 3, 5, 7, 9, 11, 13. Then you calculate 1, 2, 3, 4, 5, 6, 7. So correct, huh? Right. Okay, so then we go to example 18, right? Example 18. Okay, so this exercise is not so enough, but the concept is the same. Huh? So first thing, before you shed the region, okay, so you have to name the area. So you see, from inside the universe set, we can name the area for a separate area. Okay, so the first one is outer, so we write as 1, and then inside P there are 3 areas, 1, 2, 3. So it's 2, 3, and 4. And inside Q is 5 and 6. So inside R is 4 and 5. So therefore, when I want to do Q intersect R prime, so I need to know Q intersect R. Right? So Q intersect R prime. So what is Q? Q is, okay, you see Q, Q is, if we use highlighter, is this area, the whole area. So it's 3, 4, 5, right? So 3, 4, 5. So 3, 4, 5, sorry, 6. So by 6, and then you intersect R. Inside R is 4 and 5. So 4 and 5. So you have common area is, the common is 4 and 5. Okay. But we want prime. So prime means you don't shed 4 and 5, but you shed outside 4 and 5. So 4 and 5 you don't shed. So we only shed 1, 2, 3, and 6. So use highlighter. So 1, 2. So be careful. Don't highlight, don't shed 4 and 5. Okay. Okay, so this is how you shed. But in exam, we just do like this. Okay, so no need to shed whole thing with a pencil. Right? So, but be careful, don't shed inside here. This is considered wrong. This 2 is considered wrong. So we need to rub off. Okay, sorry. Okay, we need to rub off this. Make sure it doesn't touch. Okay, so now perfect. Okay, all right. How about P intersect Q intersect R prime? So P intersect Q intersect R, so you can P. All right, so now still use the same method. So P 2, and then in 3, 4, and 5. 1, 2, 3, 4, 5. So P intersect Q. So we list down what is P is 2, 3, 4, and 5. Okay. Then you intersect Q. Q is 3, 4. Then intersect R is 4, 5. Okay, so here you can see that P and P, Q and R has a common element, that is 4 only. So 4 only, this area lah. Okay, so therefore we only shed outside. If in complement, that's mean we only shed outside 4. Oops. Okay, so we don't shed this area. Okay, we don't shed this area because this area is P intersect Q intersect R. Okay, so we just shed outside. Okay, so outside is this area. Okay, all right. Okay, now we go for example 2 first. Okay, I think example 1 is there's something wrong with the question, right? Okay, if you read, in a survey involving 60 children, it was found that 45 of them read comics, detective story, and 5 do not read at all. Determine the number of children who read both comics and detective story. I think it's not enough information. So if I draw out, okay, this is survey, those who do survey. So of course, we are only looking at reading comics and also detective, right? Comics and detective story. So you can see that there are 5 did not read, right? So therefore, outside C and D, so C and D actually you CUD, yeah? Union. So CUD means include set C and also in set D, right? So is 60 minus 45, okay? So we have 15, okay, 15. Okay. Sorry. Hold on. Okay, 60 minus 5, sorry. Oh, yeah. 60 minus 5. 60 minus 5, we have 55. Okay, so 55 of them, right? So is that 45 of them read comics and detective story? So it's a bit blur. Reads comic and detective only, so 55. So here is altogether is 55. Okay, so if you assume those who read both, right, both comic and also detective story, so it will be here. So it will be 55. So C intersect D will be 55 minus 45. That is 10 here, right? So here is 10. So these two, we are not sure, okay? Because these two add up together is 45, right? Okay. Those who read only comics and only detective story will be 45, but the read both will be 55 minus 45 is 10. Okay, so I will check again, but I think it's a bit weird, the question, right? So then we go to this question, right? So there are 3. Okay, all right. So I think I stop here for a while. Okay, let me have a room to check, right? Right, that's all.